Good morning, class. Today, Thursday and Friday, we will be doing different things for groups A and B. If you're in group A, today, of course, we're taking a test in room 309. And if you're in group B, you're doing section 4.2.1 for a second day. There's a couple additional problems we're going to do there. And then we'll flip and do the opposite on Friday. 4.2.1 day 2 will be due on Friday at 11:59. So if you're testing today, don't worry about going home and doing this assignment. You can work on it on Friday. Before we move forward, I wanted to take just a moment and look at a compilation of a few different students' work from the previous lessons. So this is, I think it was question 48, 49, and 50. So this student for question 48 gave me a very nice looking scatter plot from Desmos. They included nice labeled axes, distance from the wall in inches, width of field of view in inches, and then the equation of the line of best fit that they got, which is they wrote down y is equal to 0.13x plus 1.7. And in this case, I can see that they rounded, I guess they rounded this to the nearest hundredth, the slope, and they rounded this to the nearest tenth, and I'm fine with that rounding unless I specify something else. The next question was, so when this point was swapped out, and it became, instead of 20 or whatever it was supposed to be, it became 10.7. The student said yes, 144 10.7 is an outlier because as Amy moves further away from the wall, the width of view would increase, not decrease. So you can see right here it's getting bigger, 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 and boom, it went down. The outlier would cause Amy's predictions to be too low. The least square regression line is pulled down because of the outlier. I know this because her other points were gradually increasing from the distance from the wall to the width of the field of view. With the width of the field of view decreasing so much, the accuracy of her data won't be correct. Well, certainly in this physical situation, right? At least we're suspicious of it. Great. Let's go on to question 49. So in 49 it says, below you can see my x and y axis are labeled, and it appears that this is a linear association that is increasing. I don't believe that there are any outliers. Okay. And I do see that it is number of toppings of pizza, not including the cheese, and the cost in dollars. The slope in this situation is the cost per topping. And you can see that, right? It's basically because it's rise over run, so it's cost per number of toppings, or cost per topping. And the y-intercept is the cost of a pizza with no toppings. Yeah, that's interesting. So we see here the equation of the line of fit, and then it looks like this student's showing me that they're putting in 2 toppings into that equation. They're getting 1050. And then again, nice sentence, right? According to the LSRL, a 2-topping pizza should cost about $10.50. So the reason why I'm selecting these is I want you to understand that if you're asked a question, right, and you just say yes, no, 1050, right? You need to be thinking about mathematics is about communication, and especially when you're typing and presenting something like this, or you're asked to write a report, make sure that you're including this information like this and you're answering the questions, the prompts in full sentences. Let's move on to the last one, which was 50, and I think some of us maybe didn't quite understand this. It looks like this student may have. So they're saying that scatter plot number 2, which is here, they've matched with the residual plot B. Okay, I'll say we'll just leave that without comment. Scatter plot 1, this one, goes with residual plot C. And I agree. I think I agree with the first one too, but I definitely agree with this because I can see at the beginning the residuals are very small. Some are positive, some are negative, but they're small numbers. And I can see as this moves out, the residuals are getting larger and larger. And that's exactly what I see here. When values of x are small, the residuals are small. And then this model apparently does a bad job of making predictions for larger values of x. And then finally, this person said scatter plot 3 goes with residual plot A. Scatter plot 3 goes with residual plot A. And I agree with that as well. In fact, you can see on this scatter plot, we have some of the points are above the curve and below, but then when I get to the middle, almost all of the residuals are negative, and then the residuals become positive again. And I can see that I see that here looking at the scatter plot, this high, low, high, but the residual plot really exaggerates that phenomena. So I've got positive residuals followed by negative residuals followed by positive residuals again. And one of the things I want you to look for in today's lesson is when you see a pattern like this in the residual, it's an indication that a linear model may not be appropriate for the data we're looking at. So when we see a pattern like this in the residual, one of our first thoughts should be, maybe this isn't a linear situation. Maybe there's some other curve we should be using to model this data. What else did this person say? The residual plot helps me make a decision because it has the least amount of negative residuals. Let's see. Scatter plot 3 has the best linear fit. Okay. So I think I might disagree with that conclusion. They're saying scatter plot 3 would be best for a linear model because it has the least amount of negative residuals. Well, I think scatter plot 2, I mean the truth is that scatter plot 2 is not a very strong association, right? When we look at it, definitely in scatter plot 3 these points are closer to the line, and you can see that it's a tighter association. Over here the association's looser, and we would say that it's a weaker association between these two variables. But because I have scatter points both above and below the line everywhere, and when I look at the residual plot, I don't see any pattern in this at all. I would say that because this is clearly random, that a linear model is probably a good fit for this data, which is kind of an interesting observation. When you look at a residual plot and you don't see a pattern, like in this one, this high, low, high, or in this one, the residuals are increasing. When you don't see a pattern like that, it's an indication that when there's no real pattern detectable here, that a linear model is probably a good fit for the data. So we're doing problems 51 and 52. I think I'm going to save 53 for, I don't know, a test or something. So 51 says, help Julia analyze the residuals for the pizza parlors in problem 49 as described below. Mark the residuals on the scatter plot you created. If you want to purchase an inexpensive pizza, should you go to a store with a positive or a negative residual? So again, as you're answering these, make sure your answer is a complete sentence. It would start with, if I wanted to purchase an inexpensive pizza, I would choose a store that had blah blah blah, right? What is the sum of the residuals? Are you surprised at this result? And then finally, make a residual plot using your calculator. Okay, and we're going to be using Desmos. So I didn't realize, but the e-tool is doing an awful lot for us, and I took away some of the things it did, because at the end of the day, you're going to need to be able to open up Desmos and enter things yourself. So you might want to do this. If I open Desmos right now with this, you might want to come down and, for example, delete this item, so that Desmos is not doing too much. Because I think my intent is that you're practicing how to use Desmos to do things. I'll remind you that changing the x-axis and y-axis labels happens with the wrench here. Some of you are having problems doing the thing, the getting the residuals yesterday, when you type the command that we discussed in class to get the least square regression line, it's important that your X and Y data is stored in the list that you're referring. So if for some reason you were to add another, if I added another table right now to this list, it would call this X2 and Y2. And if I was to type all my data in here and yet I'm still typing X1 and Y1 when I try to get the line of fit, it's not going to know what I'm talking about, or it's going to have the wrong data. So oops, make sure we're doing that. So let's go ahead and I'm just going to click this and I'll press enter for a new line. And to get my line of best fit, the command is Y1, and see it recognized right above there. Yes, it's Y1, and there's 8 elements in that list. And then tilde M X1, oops, X1, and then don't forget the plus B so it can manipulate the y-intercept. And there's our line of fit. Oh, I didn't want to show you that, but it's there anyways. So the other thing is that, well, you're going to need to do that. The other thing is that it's asking me to find the residual plot for this. So I'll just remember the residuals. You can get those values by clicking this. If I'm asking for a residual plot, I don't want to see everything else. So the residual plot would look like turning off the line of fit, turning off the scatter plot, and then stretching this, right? So here is a residual plot. In a well formatted residual plot, 0 should be pretty much down the middle of your graph. And the reason for that is, remember, some of my residuals will be positive and some will be negative. So, and the questions are repeated here. So remember, in your doc that you submit today, I want to see these things, and I also want to have complete answers, complete sentences for those questions. And then the other question that you'll be dealing with is question 52. I always like dry ice, especially at Halloween. Halloween, you can get that over at, what is it? I think I get it at Food Max. You can buy it over there. But dry ice, which is frozen carbon dioxide, has the unusual property of sublimating, changing directly from solid to a gas. And that's why it looks so cool. Julia's father uses dry ice to keep the glasses in the restaurant cold. Since ice sublimates in the restaurant cooler, Julia is curious how long a piece of dry ice would last. She collected the following data. So here's this data that she collected. And then it says, and again, if you use the CTPM tool to not have to enter the data, I understand that. But if you're not practicing doing everything else on your own and you're just clicking their buttons, you're kind of missing the point. So when I ask you to do these things in class, or I ask you to do these things on an assessment item, make sure that you've had adequate practice so that you know how to enter a table, create a table, how to enter the data correctly. You've practiced that. How to find the line of best fit, how to create a residual plot. So these are things that you can do. But it's awfully easy. It is. It's awfully easy when I click this button right here. And you can click this too. I don't like this as well because it's kind of more of a temporary view that doesn't last. When I click this one and open it up, this is super cool because all of us have Desmos accounts. And if you just log in with your school username, school password, right? Don't forget to tag on the @suhsd.net. Your account's already set up and you can save your work and build out your own items. So anyways, you can see here what I'm looking for in this. Again, as you answer this question, make sure you're writing complete sentences, and yeah, have fun. One other thing that I wanted to point out in Google Docs, let me show you this. Let me flip to it. You may have noticed how this student had the graph with some text off to the side. To accomplish that, when you click an image, one of the things that happens is you get these icons below here, and you also get the some margin information. That's just basically the gap between where the text and the writing. So if you want, you can increase that margin. I'll make it like 1/2 of an inch. Oh dear, it just reflowed the whole document. Um, but then but then it also moved all my text around. That's not what I wanted to show you. What I wanted to show you is this. This is the wrap text around. So if you choose this option, it'll make it so that you can have the text off to the left or the right of your graphic, which I think is a better presentation. If you move this graphic to the other side, you'll see that oh, geez, come on. No, that did not flow how I wanted it to. Anyways, consider playing with that because I think it looks nice when you look at this and you have the graphics embedded in your text. All right, that's it. I look forward to seeing your submissions as always, and have a great weekend.